Welcome back to the CISA Exam Prep Series. Today in Domain 3, Part B, we'll focus on information system implementation. We'll start with testing methodologies. We'll walk through the 4 essential levels from unit testing through to acceptance testing. We'll touch on the ACID principle for data integrity. Then we'll explore configuration and release management, the controls that ensure only authorized tested code makes its way into production. Then we'll dive into the go-live process itself, data conversion controls, and the 3 changeover strategies. Then we'll examine certification versus accreditation, and we'll discuss why that distinction matters for risk acceptance. Finally, we'll discuss post-implementation reviews and the ongoing change management that keeps systems secure and functional after deployment. And throughout this session, I'll emphasize the auditor's role in each phase. Let's dig in. And here in Domain 3 Part B, we'll largely be focused on topics of information system testing and implementation. And while you may know me from my exam prep content here on YouTube, in my 9 to 5 I'm a cybersecurity strategist and a vCISO for a regional bank where I'm exercising my cybersecurity knowledge every day, like that which you'll find here on the CISA exam. More importantly, last year I helped thousands achieve cybersecurity certifications, like the CISSP, CCSP, and the Security Plus exams, and I'm bringing that proven formula to you here with the CISA exam. As with all my exam prep courses, you'll find a PDF copy of this presentation available for you in the video description to leverage in your exam preparation as you require. You'll also find a clickable table of contents available in the video description, and it should appear automatically on your YouTube video timeline. And again, we see Domain 3 is a bit less than the others in terms of weight, but important foundational concepts when it comes to implementation and a lot of auditors' perspective in this session. So in our series of 5 domains covered in 10 parts, we are on installment number 6, 3B. So if we look at our syllabus here for 3B, Information System Implementation, we see it's 4 parts: testing methodologies, configuration and release management, system migration, infrastructure deployment and data conversion, and we'll wrap up with post-implementation review. But let's start with testing methodologies. Let's start with the levels of testing, really looking at this as a progression from small components on up to the entire system. So at the most granular level, we have unit testing. This is testing of an individual program or module to ensure its internal operation performs according to the specification. This is typically performed by developers. They're going to be closest to the expectation at a unit level. Integration testing, which is testing the connection and data flow between 2 or more unit-tested modules to ensure they work together as a cohesive group. Moving up the stack, we have system testing, testing the entire integrated system to verify that it meets all of our functional and technical requirements. This is typically going to be performed by the test team in a non-production environment. Then finally, we have acceptance testing. This is the final gate before implementation. This is where users validate that the system meets their business needs. So that's the high level. Let's drill down on the different types of system testing, because there are multiple specialized tests at a system level to ensure that our system is robust and production ready. There's recovery testing, which checks the system's ability to recover after a hardware or software failure. There's security testing that verifies our access controls are working and that no new security holes have been introduced. And then there's volume, load, and stress testing. These are not quite as self-explanatory on first glance. There's load testing, which evaluates performance with large quantities of data, like peak hours type load. Volume testing, which would determine the maximum volume of records the system can handle. and stress testing, which determines the maximum number of concurrent users the system can handle. But performance testing comes into play here as well, which compares the underlying system's performance against defined benchmarks while we have that activity underway. So next, let's talk acceptance testing. So we have two major types of acceptance testing you want to be familiar with. There's first quality assurance testing, which covers the technical aspects of the system. So this is typically going to be performed by the IT department. Its purpose is to verify the application works as documented and it meets all technical specifications. Answers the question, did we build the system right? And then we have user acceptance testing, which covers the functional aspects and the business readiness of the application. This is going to be performed by business end users or their test-focused delegates. It ensures the system is production ready and satisfies all documented business requirements from a user's perspective. This is the final sign-off. And UAT answers the question, did we build the right system? So from the technical perspective, we're looking just to make sure the system functions as it's documented. And when we look at user acceptance testing, it's making sure those functions are built in a way that's useful to the business. So for the exam, remember UAT is the most critical milestone before implementation, and it's the business users, not the IT department, that give the final approval to go live. So let's talk through a few other testing methods. There's alpha and beta testing. So alpha testing is an early form of testing. It's often performed by users within the development organization. Some systems testing, really just getting a gut check that we're progressing in the right direction, kind of a qualitative check often. Beta testing is a form of user acceptance testing where the system is released to a limited number of external users for real-world exposure. That might be a business stakeholder and perhaps some team members where they can take a look and make sure that we are trending toward building the right system. There's white box and black box testing. So white box testing tests the internal logic and the structure of the code. So right there, that tells us for white box testing, source code access is required. The tester can see inside the box. This is used in unit and integration testing. Then we have black box testing, which tests system functionality without any knowledge of the internal code. Typically, this is testing the application code while it is running. So there is no source code access. This is going to be used in integration and acceptance testing, and here the tester only sees the inputs and the outputs. And there are a handful of other testing methods you want to be familiar with. There's pilot testing, which is a preliminary test that focuses on specific predetermined aspects of a system in a limited evaluation. Regression testing, which is a rerunning of test cases after a change or a correction to ensure that the change has not introduced new errors into previously working code. And then parallel testing. So this is feeding test data into both the old and new systems and comparing the results to verify the new system's performance. Bottom-up testing. So bottom-up testing begins with testing individual atomic units like programs or modules, and it works upward until the complete system is tested. The advantage here is errors in critical low-level modules are found early in the process, so it's going to be faster, easier, and cheaper to fix them. The flow would typically be unit testing, integration testing, and system testing. So the unit tests the individual atomic units. Integration, you remember, tests the data flow between the validated units. And then system testing is covering the system as a whole. This is going to be the typical strategy for large applications. The more complex it is, the more likely you're going to see the bottom-up approach because we can catch those issues early. Then there's top-down testing, which starts by testing major functions and interfaces at a high level and then working down to the details of the individual modules. So the advantages for top-down would be that it tests the major functions and processes early in the process of or development, the interface errors can be detected sooner from a user perspective potentially. The users are seeing a working version of the system early, which will increase their confidence, and in an agile project methodology, it allows them to provide meaningful feedback in earlier sprints of the development process. Let's talk data integrity testing and the ACID principle. So data integrity testing examines the accuracy, completeness, consistency, and the authorization of data. There's relational integrity, which ensures data elements conform to validation rules. For example, that a date field contains a valid date. There's referential integrity, which ensures relationships between tables in a relational database are consistent. For example, an order can't exist for a non-existent customer. The ACID principle speaks to the transaction itself. So there's atomicity, which states all parts of a transaction complete or none do. There are no partial updates. Consistency, where the transaction brings the database from one valid state to another. So consistency speaks to the state of the database before and after a transaction. Isolation, concurrent transactions do not interfere with each other. And durability, once a transaction is committed, it survives system failures. You definitely want to be familiar with the ACID principle for game day. Let's take a look at application systems testing techniques. These are techniques used to test the effectiveness of application controls. These are often conducted using generalized audit software for independent verification. GAS is a class of computer-assisted audit techniques. These are going to do some of the heavy lifting when it comes to data extraction, querying, manipulation, summarization, and analytical tasks. So just comparing techniques, we have test data, which simulates transactions through real programs to verify controls and edits, just to see if the system's controls catch errors. Parallel operation, where we process production data through both new and existing systems at the same time and compare the results to make sure we have consistency. We see expected results. Integrated test facility. This creates a fictitious file or entity in the live production database to process test transactions simultaneously with live data. So in the real world, for example, if we were looking at an airline ticket booking website, they may have a fictitious location so they can actually perform a synthetic transaction to make sure that the system is functional all the way to the back end, ensuring customers are able to purchase as they believe. Parallel simulation. This processes production data using computer programs that simulate the application's logic to independently verify the results of the live system. Of these, I would say the integrated test facility is highly probable as an exam topic. Be the most likely of the four to come up on the exam. Let's talk about your focus as an information system auditor during testing. So your primary focus is to provide independent assurance over the entire process. You review the test plan, ensure the plan is complete, adequately test controls, shows evidence of proper user participation and sign-off, data reconciliation, reconciling control totals and reviewing converted data to ensure accuracy and completeness. Review error handling, examine error reports, verify that they accurately recognize erroneous data, and that a process exists to resolve those errors. Interview users, speak with end users to gauge their understanding of the new system, the methods and operating instructions. We want to make sure the users know and understand what they're working with. And then reviewing security, developing and executing access tests to verify that the system security is functioning as designed. So you want to make sure that you keep your focus at that high level over the entire process. So let's talk about configuration and release management, 3B2. Configuration and release management are so important because they help us to maintain control during implementation. So configuration management is the process of identifying, defining, and baselining all components of a system, hardware, software, documentation, and controlling changes to them throughout their life cycle. The configuration management database is the central repository that stores all the information on the hardware and software assets and their relationships. And will generally have links to their documentation as well. Release management is the process of managing, planning, scheduling, and controlling a software build throughout the different stages and environments. And that includes testing and deploying releases into production. The key control here is that a new version of a system should only be built from a trusted, baselined set of items stored in a controlled library. So that baseline is the trusted source for recovery. All of this assumes you are very familiar with two terms, and I made an assumption here that the official study material also makes, and that's that you know the difference between baseline and baselined, and you know what each of these means very well. So just in case that's not true, let's talk about it. The baseline is the official approved version of a system or component at a specific point in time. Think of it as a gold standard snapshot. It would be a version. Baselined is a verb. This means a system has been formally reviewed, approved, and locked in as part of the official master copy. And once an item is baselined, any future modifications have to go through the formal change management process. We have to submit a change control that will be approved and tracked. This ensures that only authorized and tested changes are made to the trusted system. And that brings us to 3B3, System Migration, Infrastructure Deployment, and Data Conversion. So let's talk through system implementation and planning. So implementation is initiated only after a successful testing phase, and we have appropriate sign-offs. A key part of implementation is planning for the system's ongoing operational life after we deploy, including a detailed support structure and training plan, which means we need to think about how we're going to transfer that knowledge from development to operations. Our key methods here would include shadowing, which would allow support staff to become accustomed to the new system by observing the project team in action. And we will want to do this before we get to that final release day. The relay baton approach, which transfers knowledge and responsibility in small manageable portions to ensure a transparent and controlled handover. So that's a great approach for a busy team that doesn't have an entire day or a week to stop what they're doing, supporting operations, to learn this new application or system. The training plan is the formal plan needed to address any skill gaps. It should define content, scheduling, duration, and the delivery mechanism. For example, is this classroom training? Is it web-based on-demand training, etc.? Let's talk about the go live process. The go live phase is where all these pieces come together. We need to think about data conversion and migration. This is the process of converting and moving data from the old legacy system to the new system. And the changeover is the approach used to switch from the old system to the new system. There's end user training, the process of preparing users to operate the new system effectively. Certification and accreditation. So this is the formal process of evaluating and accepting the system for production use after implementation. This is that formal sign-off and handover. So let's talk about data conversion, and then we'll come back to accreditation. So our objective with data conversion is to convert our existing data into a new format while preserving its meaning, integrity, accuracy, and completeness. From an auditor perspective, our key concerns here are data cleansing. So was the data cleansed before conversion? Verification, were the record counts and control totals used to verify success? So did we quantitatively verify success? Were logs created to document the conversion? Is there a documented and tested rollback plan to reverse the data migration if a critical failure occurs? So for the exam, a couple of things here. An information system auditor must verify that a rollback plan not only exists, but it's actually been tested. The best way to know if your rollback plan works is just like testing your data backups. Actually run through them, test them, make sure they function. A migration should not proceed without a proven way to revert to the previous stable state of the system. So a large-scale data conversion really feels like a project within a project, and it requires some pretty rigorous controls. We need to be careful about this migration. Some key steps and controls for the auditor to verify. We talked about data cleansing. Was it cleansed before conversion? Were the record counts and control totals used to verify success? Do we have an audit trail that documented the conversion? So if there's anything in doubt, we can go back and look at that log. Also, acceptance reports. Is there a process to report any items that could not be converted automatically for manual review? And then a conversion dress rehearsal. Was the end-to-end conversion process tested with real data to familiarize staff and test the process before the live event? When we are converting data for the live event, that should not be the first time we've converted the data. We should have walked through this before in a practice run to make sure we know it works. So on game day, it functions exactly as we expect. As an auditor, your primary concern during data migration is the integrity, accuracy, and completeness of the data. You can only imagine if we miss on any one of those three, if it's customer data, customer orders, the customer's transaction history, etc., that's all going to be a meaningful loss to the business. So let's talk about the changeover process, what we call go live strategies. And you'll need to know the risk-reward trade-offs for each of the three major changeover strategies. I will make that easy for you. So the first is parallel changeover, which is about what it sounds like. The old system and new systems run in parallel for a period. All transactions are processed in both systems. This is going to be lowest risk. It provides an easy fallback. On the downside, the con is that it's highest cost and it is resource intensive because we have two full systems running. There's the phased changeover, where the new system is implemented by modules or department one piece at a time. So the upside, the pro there, is that moderates risk a bit. It also reduces costs somewhat. It can have some resource challenges because we're implementing new pieces of the system one at a time. So new system pieces and old system pieces have to work together during that interim period. That can result in some interesting challenges. And then there is the abrupt changeover process, also called direct changeover. We turn the old system off. We turn the new system on. The pro there is its lowest cost. The con is that it's highest risk. There's not much fallback if the new system fails. The parallel changeover option is the safest and at the same time the most expensive. So if I were to just visualize that for you another way, parallel changeover, highest cost, lowest risk. The phased changeover moderates each of these, so it's going to fall into the medium range. And then the abrupt changeover is lowest cost, highest risk. So let's circle back on acceptance and accreditation quickly. So certification is a comprehensive technical process where an assessor performs a comprehensive assessment of a system's management, operational, and technical controls against a standard. It provides the factual basis for an accreditation decision. So accreditation, on the other hand, is a formal management decision by a senior official to authorize the operation of an information system and to explicitly accept the residual risk to the enterprise. So for the exam, remember, accreditation is the final step. It is the formal acceptance of residual risk by business management, not by the IT department or auditors. The business owns the decision. Think of certification as passing the driving test. That's the technical aspect of being ready to drive. Accreditation is when the Department of Motor Vehicles issues you a driver's license, the formal acceptance of the risk of allowing you to drive lawfully on the road. So let's talk post-go live, ongoing change management. So after implementation, the system enters the ongoing maintenance stage where changes are made to correct errors or enhance functionality over time, repeatedly. The change control process from development has to continue to be enforced in the production environment. From an auditor's perspective, your review here would be to confirm all system change requests from users are formally authorized, prioritized, and tracked, that there are formal documented procedures for handling emergency changes, verifying security is adequate to restrict access to production source and executable code, ensuring the change control log is available and ensures that all changes shown were resolved, and confirming changes are tested adequately before being moved to production. All right, that brings us to 3B4, post-implementation review. So looking back at our implementation process. The purpose here is to determine whether the project and the new system have met their objectives and to identify lessons learned for future projects so we can do it better next time. The timing here is important. The post-implementation review is typically conducted several weeks or even months after implementation once the system has stabilized. Because after we hand off, especially a very large system to production, there can be some bugs that need to be worked out in production that we, for one reason or another, didn't catch through our test phases. And I've seen this in exceedingly complex systems where folks will work around the clock for a period of days. We have teams in there 24/7 just working out the minor issues. But this is different from project closure, which happens immediately. We close a project, but the post-implementation review happens a few weeks out. So key areas to review here would include adequacy of the system. So does the system meet user requirements and business objectives, what we were expecting when we undertook this project? So are controls working effectively? Projected cost versus benefits. So the benefits realization, which is of utmost importance here. It's not just finishing the project on time and under budget, is did we also realize the business benefits that were expected? Assessment of the project process. Were project management methodologies and standards followed, and what lessons did we learn there? So as an auditor, your role in this, you must be independent from the development of the system itself. An auditor who consulted heavily on the project shouldn't perform the post-implementation review because you have a horse in this race, as we say. You were involved in this, so you are going to be biased for its success. So you will be naturally less likely to be objective in criticisms of the process and the results. Your focus as an auditor concentrates on review of control aspects of the system and the project management process itself. Some key audit steps here. Determine if system objectives and requirements were actually achieved. Verify the cost benefits from the business case, that formal document that kicked this project off, that the benefits from the business case are being measured and reported. Review controls to ensure they are operating as designed in the live production environment. And review operators' error logs, help desk tickets, change requests to identify any systemic problems. So let's talk about some key takeaways from Domain 3B. So you want to master the testing levels, know the sequence and the purpose of unit testing, integration testing, system testing, and acceptance testing. We talked about QAT and UAT early on. Be able to clearly explain the difference between white box and black box testing, alpha versus beta, load, volume, and stress testing. Particularly with load, volume, and stress testing, I think the difference between those is not inherently obvious by their name, so you'll want to circle back with the PDF and have a look and listen again on the video if you need to. Know the go-live strategies. Understand the risk-cost trade-offs of parallel, phased, and abrupt changeover. You need to know those three and how they compare. Make sure you understand data conversion risks, especially the need for a tested rollback plan and the importance of configuration release management controls, controlling that release process. And remember, accreditation equals risk acceptance. Understand that accreditation at that formal handoff, that's the formal acceptance of residual risk by business management. Remember, management owns that decision, not IT, not the auditor. All right, my friends, that's what I have for you in Domain 3 Part B. I hope you're getting value from the series. As always, any questions, drop them in the comments. Ping me on LinkedIn. Happy to help anywhere I can. I will be back to you with Domain 4 Part A in just a couple of days. And until next time, take care and stay safe.